join us virtually and be a part of this prestigious event hosted by the Oxford College of Engineering. Stay tuned for the expert discussions and insightful sessions across the globe.
No, that link if you send, no, I will share it in a big group. Send the link.
Share the link. Wrong sharing.
I request all to maintain silence, switch off your mobile phones, don't roam around the auditoriums during the start of the session. Watch live streaming at the Oxford College of Engineering. It's live now in YouTube. I request all to put your mobile phones in silence and maintain silence.
All now.
I request everyone to switch off your mobile phones, maintain silence. The dignitaries will be arriving in another 5 to 10 minutes.
It is proper, no?
Don't roam around the auditorium during the start of the session.
Where is Hindu ma'am? Hindu ma'am, and that is happening from day to day.
ಹಲೋ ಮೈಕ್ ಟೆಸ್ಟಿಂಗ್ ಕರೆಕ್ಟ್ ಆಗಿದೆಯಲ್ಲ ಸೌಂಡ್ ಪರ್ಫೆಕ್ಟ್ ಅಲ್ಲ
Front seat shouldn't be empty. यहाँ आ जाओ. Anup sir, Saravanan sir, come. Guys, come here. Boys, come here.
आ रहे हो लोग
Over here.
I request all to maintain silence. Switch off your mobile phones.
They started. Go fast. They started.
Are arriving in another 2 minutes.
नहीं वाईफाई will disconnect Run hotspot faster
campus-based university, which is very, very good. Marine robotics. Are you doing just building robots for bearing? Bearing robots for bearing applications? Yes. For ships or military? Yes, energy use, yeah.
Hands up!
Legs up. Legs up.
Ladies and gentlemen, we are requesting to kindly raise and join me in extending a warm welcome to our esteemed guests for the IEEE ICCCNP 2025 conference at the Oxford College of Engineering.
Go friend.
Requesting everyone to join your hands
Excuse me, sir. Excuse me.
to receive our esteemed chief guest. Requesting everyone to join your hands to welcome our esteemed guest. Requesting everyone to please seated. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ ಹಾಗೂ ಶುಭೋದಯ. IEEE ICCCNP 2025 ವಿಭಾಗಗಳ ಅಂತಾರಾಷ್ಟ್ರೀಯ ಸಮ್ಮೇಳನಕ್ಕೆ ಆಗಮಿಸಿರುವ ಎಲ್ಲ ಗಣ್ಯ ಅತಿಥಿಗಳು, ವಿದ್ವಾಂಸರು, ಪ್ರತಿನಿಧಿಗಳು ಮತ್ತು ಪಾಲ್ಗೊಳ್ಳುವ ಎಲ್ಲರಿಗೂ ದ ಆಕ್ಸ್ಫರ್ಡ್ ಇಂಜಿನಿಯರಿಂಗ್ ಕಾಲೇಜ್ ವತಿಯಿಂದ ಹೃತ್ಪೂರ್ವಕವಾದ ಸ್ವಾಗತವನ್ನು ಬಯಸುತ್ತಿದ್ದೇನೆ.
A very good morning to one and all present here. On behalf of the organizing committee and the Oxford Educational Institution, it gives me immense pleasure to welcome you all to the inaugural ceremony of IEEE Conference on Compute, Control, Network and Photonics 2025. The best way to predict the future is to invent it, said by Alan Kay. This quote truly reflects the spirit of today's gathering, where brilliant minds, innovative ideas, and cutting-edge research come together to shape the future of technology. Conferences like this are not just platform for knowledge exchange, but also the starting point for inventions that transforms our world. We are honored to have with us distinguished guests, eminent speakers, academicians, researchers, students, press and media, all united by the vision of technological excellence and innovation. Let's come together to learn, share, and pave the way for a brighter, technologically empowered tomorrow. On the behalf of Founder Chairman, Principal, Director, Management, Staff, students of the Oxford College of Engineering, I, Shruti K. Reddy, Assistant Professor of Department of Computer Science and Engineering, deem it a great pleasure to stand before you all to extend a warm welcome on this important occasion. We are truly honored to be your host for your today's prestigious event, guiding you to the various sessions of this remarkable gathering. It's our tradition to seek the blessing of Almighty before the start of any auspicious event. I request Bhavani to render the invocation song. Om Shri Ganeshaya Namah. Chandrachooda Shiva Shankara Parvati Ramana Ninage Namo Namah. Chandrachooda Shiva Shankara Parvati Ramana Ninage Namo Namah. Sundaratara Pinakadara Hara Sundaratara Pinakadara Hara Gangadhara Gajacharamambaradhara Gangadhara Gajacharamambaradhara Chandrachooda Shiva Shankara Parvati Ramana Ninage Namo Namah. Chandrachooda Shiva Shankara Parvati Ramana Ninage Namo Namah. ಕೊರಳಲಿ ಭಸ್ಮ ರುದ್ರಾಕ್ಷವ ಧರಿಸಿದ ಪರಮ ವೈಷ್ಣವನು ನೀನೆ. ಕೊರಳಲಿ ಭಸ್ಮ ರುದ್ರಾಕ್ಷವ ಧರಿಸಿದ ಪರಮ ವೈಷ್ಣವನು ನೀನೆ. ಗರುಡ ಗಮನ ನಮ ಪುರಂದರ ವಿಠಲನ ಗರುಡ ಗಮನ ನಮ ಪುರಂದರ ವಿಠಲನ ಪ್ರಾಣ ಪ್ರಿಯನು ನೀನೇ. ಚಂದ್ರಚೂಡ ಶಿವ ಶಂಕರ ಪಾರ್ವತಿ ರಮಣ ನಿನಗೆ ನಮೋ ನಮಃ. ಚಂದ್ರಚೂಡ ಶಿವ ಶಂಕರ ಪಾರ್ವತಿ ರಮಣ ನಿನಗೆ ನಮೋ ನಮಃ. ರಮಣ ನಿನಗೆ ನಮೋ ನಮಃ. ನಮೋ ನಮಃ. Namo Namaha. Thank you, Bhavani, for that soulful invocation song. It's truly a beautiful tone for the morning. Deepa Deva Mahajyoti Ajnana Tamasahara Satya Jnana Pradaniye Namaste Shubha Deepike. We bow to the sacred lamp that removes ignorance, bestows knowledge, brings auspiciousness and blesses everyone with wisdom and prosperity. I would request all the dignitaries to kindly join for lamp lighting.
Manjuna sir, Rita ma'am, Dr. Shrina, please join. Shakuntala ma'am. The dignitaries, all the dignitaries, please come. Viva, please join us on the stage. Come.
Thank you. Now I call upon Professor Indu and team for Nadamite. I will request everyone to kindly raise up for Nadamite.
जय भारत जननीय तनु जाते, जय हे कर्नाटक माते, जय सुंदर नदी वनಗಳ ನಾಡೆ, जय हे रस ಋಷಿಗಳ ನೀಡೆ, ಭೂದೇವಿಯ ಮಕುಟದ ನವಮಣಿಯೇ, ಗಂಧದ ಚಂದದ ಹೊನ್ನಿನ ಗಣಿಯೇ, ರಾಘವ ಮಧುಸೂದನರವತರಿಸಿದ ಭಾರತ ಜನನಿಯ ತನು ಜಾತೆ, जय हे कर्नाटक माते, ಜನನಿಯ ಜೋಗುಳ ವೇದದ ಘೋಷ, ಜನನಿಗೆ ಜೀವವು ನಿನ್ನಾವೇಶ, ಹಸುರಿನ ಗಿರಿಗಳ ಸಾಲೆ, ನಿನ್ನಯ ಕೊರಳಿನ ಮಾಲೆ, ಕಪಿಲ ಪತಂಜಲ ಗೌತಮ ಜಿನನುತ ಭಾರತ ಜನನಿ ಜಾತೆ, ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ, ಶಂಕರ ರಮನುಜ ವಿದ್ಯಾರಣ್ಯ ಬಸವೇಶ್ವರ ಮಧ್ವರ ದಿವ್ಯಾರಣ್ಯ, ರನ್ನ ಷಡಕ್ಷರಿ ಪೊನ್ನ ಪಂಪಲ ಕುವಿಪತಿ ಜನ್ನ, ಕುಮಾರ ವ್ಯಾಸರ ಮಂಗಳಧಾಮ, ಕವಿ ಕೋಗಿಲೆಗಳ ಪುಣ್ಯಾರಾಮ, ನಾನಕ ರಾಮಾನಂದ ಕಬೀರರ ಭಾರತ ಜನನಿಯ ತನು ಜಾತೆ, ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ, ತೈಲಪ ಹೊಯ್ಸಳರಾಳಿದ ನಾಡೆ, ಕಂಕಣ ಜಕಣರ ಮೆಚ್ಚಿನ ಬೀಡೆ, ಕೃಷ್ಣ ಶರಾವತಿ ತುಂಗ, ಕಾವೇರಿಯವರ ರಂಗ, ಚೈತನ್ಯ ಪರಮಹಂಸ ವಿವೇಕರ ಭಾರತ ಜನನಿಯ ತನು ಜಾತೆ, ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ, ಸರ್ವ ಜನಾಂಗದ ಶಾಂತಿಯ ತೋಟ, ರಸಿಕರ ಕಂಗಳ ಸೆಳೆಯುವ ನೋಟ, ಹಿಂದೂ ಕ್ರೈಸ್ತ ಮುಸಲ್ಮಾನ, ಪಾರಸಿಕ ಜೈನರುದ್ಯಾನ, ಜನಕನ ಹೋಲುವ ದೊರೆಗಳ ಧಾಮ, ಗಾಯಕ ವೈಣಿಕರಾರಾಮ, ಕನ್ನಡ ನುಡಿ ಕುಣಿದಾಡುವ ಗೇಹ, ಕನ್ನಡ ತಾಯಿಯ ಮಕ್ಕಳ ದೇಹ, ಜೈ ಭಾರತ ಜನನಿಯ ತನು ಜಾತೆ, ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ, ಜಯ ಸುಂದರ ನದಿ ವನಗಳ ನಾಡೆ, ಜಯ ಹೇ ರಸ ಋಷಿಗಳ ಬೀಡೆ, ಜೈ ಭಾರತ ಜನನಿಯ ತನು ಜಾತೆ, ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ, ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ, ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ.
Thank you, ma'am. I request everyone to be kindly seated. As the saying goes, a leader is the one who knows the way, goes the way, and shows the way. To welcome this gathering, I now invite our respected Principal and Director of the Oxford College of Engineering, Dr. H.N. Ramesh, to welcome address.
Good morning. Dignitaries on the dais, dignitaries of the dais, my dear esteemed colleagues of the Oxford College of Engineering and Oxford institutions, educational institutions, keynote speakers, delegates, session chairs, invitees, print and electronic media persons, ladies and gentlemen. I heartily welcome you all to this IEEE International Conference on Compute, Control, Networks and Photonics, ICCCNP 2025. The conference is a prestigious platform that brings together academicians, researchers, industry leaders, innovators, and students from across India and abroad to deliberate upon the latest advances in computing technologies, control system, networking solutions and photonics. These 4 domains actually are not only independently impactful but also deeply interconnected in shaping the future of science, engineering and the society at large. So in this occasion, it gives me great pleasure to welcome in absentia our Honorable Chairman, the President of Children's Education Society, the Oxford Institutions, Educational Institutions, Dr. SNVL Narasimharaju Garu. On behalf of the organizers, I am delighted to welcome Sri Vikas Gadi, the Senior Director of R&D Synopsys Bengaluru. We are honored actually to welcome the guest of honor, Dr. Francisco, Constructor University, Germany. We are really privileged to welcome the guest of honor, Dr. Fakadu, Bahidar University, Ethiopia. I also would like to welcome Dr. Srinivas Talabatula, Professor, Department of ICCCNP, Indian Institute of Science, Bangalore. I would like to welcome Ms. S.N. Leela Lakshmi Raju, young and dynamic academic leader of the Oxford Educational Institutions. I would like to welcome Dr. Srinath, the management representative of the Oxford Educational Institutions. I would like to welcome Dr. B.K. Manjunath, the Vice Principal and Head of the Department Biotechnology, Oxford College of Engineering, and General Chair of IEEE ICCCNP 2025. I also welcome Dr. Preeta Shannon, Dean R&D and the Conference Chair. I welcome Srimati Shakuntala Madam, the Honorable Management Representative, the Oxford Educational Institution. I also welcome the Young Management Representative, Kumari Vibha. I welcome all the HODs of various departments of the Oxford College of Engineering, faculty members, administrative and non-teaching staff, and the students of the Oxford College of Engineering. Also, I would like to welcome all the principals, faculty members of the Oxford Educational Institutions. Lastly, but not the least, I welcome the delegates, students, media persons, and all the invitees to the conference. Thank you.
I now welcome our honored and beloved Principal, Dr. H.N. Ramesh, for this prestigious IEEE ICCCNP 2025 conference. Thank you, sir, for your inspiring welcome address. Your words have set a wonderful tone for the conference. To present the vision, scope and objective of IEEE ICCCNP 2025, I invite our IEEE Conference General Chair, Dr. B.K. Manjunath, Vice Principal, Professor and Head of Biotechnology Department to give us an overview of the conference.
Good morning each and everybody assembled here, respected dignitaries on the dais, of the dais. It's my privilege to stand in front of you to give the overview of today's conference, ICCCNP, sponsored by IEEE. The journey of this ICCCNP started in 2024 with the intention of providing a technical platform for academicians, industry persons, researchers, innovators, keeping the cutting-edge technologies in the mind. When we approached our Honorable Chairman, Dr. S.N.V.L. Narasimha Garu, for organizing such an event, he kindly consented it. Then former principal, Dr. Kannan, initiated the journey, and with the continuous and encouraging guidelines from the management and management representative, Dr. Srinath, and the present principal, Dr. S.N. Ramesh, we would be able to stand in front of you today to have an inaugural event of this prestigious ICCCNP conference. We have received around 441 technical people across the globe, and following the double-blind scrutiny, we were able to shortlist 70 research papers. It doesn't mean that others are not qualified, but keeping a highest standard in the mind, we were able to provide acceptance for 70 papers, which covered across the globe, including IITs, NITs, IIITs, and abroad universities. And today, all these 70 papers are going to be presented in front of the panel under 4 different tracks. Hope our effort will enrich your knowledge and opens up collaborative and innovative interaction among yourselves. Then we have, considering the other papers and the interest shown by the participant, we decided to have poster presentation also. And in the venue, we have arranged around 37 shortlisted technical presentations as a poster forum. Please do visit the stall. And when we approach industry personnel to provide a platform for interacting with the academicians, they were kind enough to come forward and sponsor the event. So we are thankful to all the sponsors who are there to support us. And today we have around 7 sponsors stall in the venue. Please, students and faculty and the participants, go and interact with them and take the benefit out of it. So our effort to provide technical platform for the academicians and to bridge the gap between academia and industry is on. With this motto, we have started the journey, and today we are fortunate to stand in front of you and present you the international conference ICCCNP. Hope our effort will make you more innovative. I thank all the track coordinators, TCP members, and all innovators, and especially our IEEE mentor, Dr. Srinivas sir, for mentoring us throughout our journey. And I also thank all the faculty, HODs, and other members who have supported us and for making us this event a grand success. I thank one and all present here. I thank you very much, and I expect the same type of support from your end in our next endeavor. Thank you very much.
Thank you, sir, for your well-defined and insightful address at today's IEEE ICCCNP 2025 conference. Your words have truly broadened our perspectives and inspired us to explore new horizons in research and innovation. Thank you, sir. Now I call upon Professor Bindyashri from Information Science and Engineering to deliver the chairman's profile.
At the outset, it gives me immense pleasure to introduce the esteemed chairman of the Oxford Group of Institutions, Dr. S.N.V.L. Narasimha Garu. Under his visionary leadership and unwavering commitment to excellence in education, the institution has achieved remarkable milestones in academic and research endeavors. Dr. S.N.V.L. Narasimha Garu is a philanthropist whose dedication has transformed the educational and social landscape in Karnataka and beyond. With over 45 years in education, he transformed the Oxford education institutions from a small Kannada medium school in 1974 into a hub with 23,000 plus students across medical, engineering, management and more. As a strong believer in technology-driven learning, he has fostered research, innovation and global exposure for students. His work includes free education for 5,000 underprivileged children and free healthcare through Oxford Medical and Dental Colleges. Honored with doctorate by Karnataka State Open University and recognized as a model employer by the Hindu Group. He continues to shape educational policies in Karnataka. With Atal Tinkering Labs and entrepreneurship programs, he empowers students for future global challenges. We welcome him in his absence. Now, I am honored to invite Ms. Leela Lakshmi Raju, Management Member, Academic Head, the Oxford Education Institutions, to address the gathering.
Good morning to one and all present here. Respected dignitaries, Dr. S.N.V.L. Narasimha Raju, President, Children's Education Society, Chairman, the Oxford Education Institutions, who couldn't be here today with us today. Chief guest, Shri Vikas Gadi, Senior Director, Synopsys Bengaluru. Guest of honor, Dr. Francesco, Constructor University, Germany. Dr. Fakuda, Bahirdar University, Ethiopia. Dr. H.N. Ramesh, Principal, the Oxford College of Engineering. General Chair, Dr. B.K. Manjunath, Vice Principal, the Oxford College of Engineering. Dignitaries of the dais, Ms. Shakuntala, Management Representative, Dr. Srinath. I welcome you all to the ICCCNP 2025 IEEE conference at the Oxford College of Engineering. It gives me immense pleasure to be here with all of you today. The Oxford Education Institution was founded in the year 1974 with the vision of a teacher who wanted to provide quality education and empower students to face the ever-changing challenges of the world. Our founder, Sri S. Narsaraju Garu, founded this institution with 2 teachers and 24 students. And today, we proudly educate more than 30,000 students with a faculty of over 2,500 faculty under 32 institutions. Carrying forward this legacy under the able leadership of Dr. S.N.V.L. Narasimha Raju, with a vision to provide world-class infrastructure, where we are coming up with 8 infrastructural projects across our medical college and our engineering college, with a multi-facility indoor sports arena and a multi-speciality hospital, cutting-edge facilities and an environment that nurtures children, that nurtures learners and growth. It is under his leadership that the Oxford Education Institutions and the Oxford College of Engineering has consistently encouraged innovation, research and academic excellence, making conferences like this possible. Today's gathering is a reflection of that vision. To bring together researchers, academicians, industry experts, industry leaders and students on a common platform to discuss cutting-edge development in computing, control, network and phonetics. Bringing this conference to life is an effort of many and it takes a lot of time. So I thank the principal, the vice principal, the management representatives and everybody who has worked tirelessly and who has been involved to make this event possible today and to bring this conference together. I wish you all a very great success, and I am confident that this conference will not only provide new insights but also open doors to new collaborations, innovations and growth in areas that define the future of technology. With that, I once again welcome you all to this conference and a very congratulations and all the best for the next 2 days. Thank you.
Thank you, ma'am, for your motivational speech. Now, I am privileged to invite Dr. Srinath, Director, the Oxford Educational Institutions, to address the gathering.
Good morning to all, and indeed a warm welcome to all the dignitaries on the dais, dignitaries of the dais, Ms. Shakuntala Madam, Ms. Vibha, Mr. Munesh, distinguished guests, delegates, participants, and our beloved Oxfordites who are all present over here. At the outset, with great pride and deep sense of responsibility, I would like to thank the Oxford College of Engineering and each and everyone who is involved in hosting this beautiful international conference as a part of series of our Golden Jubilee celebrations. As we speak, we are celebrating our Golden Jubilee, that we are in the 50th year, where we are providing excellence in education as well as nurturing young minds. This event coming as a part of our Golden Jubilee celebration, we are feeling privileged. That's the reason I am thanking all of you. Again, I wish to welcome all the members who have gathered around here to have a thought-provoking discussions and insightful technical innovation sessions on emerging trends going forward. Here at the Oxford Educational Group of Institutions, under the visionary leadership of Dr. SNVL Narasimharaju sir, our Honorable Chairman, each and every institution is intertwined in a landscaping evolving of technology and multidisciplinary facets. We focus on multidisciplinary, where each and institution, particularly Oxford College of Engineering, is tasked to not only keep up with the pace of the rapid growing technology, but also to lead with innovation, compassion, and excellence. In the current scenario, the world of science and technology and engineering is rapidly evolving and undergoing a remarkable transformation, wherein the boundaries between engineering, medical, dental, allied health sciences, and data sciences are quickly dissolving, giving a way for a new era of technology-driven era backed up by artificial intelligence, which is now booming. It is advancing in such a pace that artificial intelligence is playing a key role in providing personalized and predictive care in medical treatments, as well as in our UPA payments, as well as our drone systems, and currently we are witnessing in our Bamanali region driverless metros. That is a pace with the advancements that technology is growing. In line with that, we at Oxford institutions, under the leadership of our chairman, we believe that preparing students for future generations, which is rapidly advancing, requires us to evolve a new methodology of teaching, which our chairman visions to build a technology-enabled learning platform, where we feel that teaching should be integrated with technology, and into our pedagogies we need to imbibe interdisciplinary and global concepts which can lead to development of the students in the further nature. When we are brainstorming on this, we understood that to keep abreast with the technology and to make our students future ready, first we need to motivate our internal faculty members and keep them abreast with the technology. In line with this, our Honorable Chairman has established research clusters across our 32 institutions, where like-minded people from different institutions are gathered. They sit together, they brainstorm, they conceive an idea and convert it into a research concept, further into a research project, further into a paper, then into a project, then patent, then they go to product, and further it goes to incubation. We are thankful for our chairman to creating a holistic mechanism where from end-to-end process we are able to deliver the thing. I am also glad and happy to say that this initiative has already yielded results. The campus where we are sitting is our dental college, where our engineering people have collaborated with our dental college people and our physiotherapy staff and have developed multiple products which are tried, tested and patented and are effectively being implemented in our patient care access areas, in our hospitals in dental and physiotherapy. Taking inspiration from there, as we sit and speak here, our medical college people and pharmacy college people are collaborating with our engineering and domain experts as domain experts and they are working on multiple facets of developing innovative tools for impactful patient care. That's one thing which is going on. Also, we requested our management to strengthen our incubation centers. The kind of support what we receive from our management is that our Honorable Chairman has graciously accepted to strengthen our incubation center. The reason why we want to strengthen our incubation is, when we interacted with our alumni, we found that in the college days, they are more interested in research or innovation. But when we go back to the industry, they are not getting the time. So we are dedicating our 3 of our incubation centers only to our alumni who can come back and sit together and they can work with us. That is one thing. And new advancement in the feather of ours is, we requested our chairman sir to provide with us a center of excellence for innovation. The purpose of that innovation center is to support all the innovators by creating all facilities, and even our management is providing a research seed grant of 5 lakh rupees for each and every idea which can be scalable. It has not ended there. Our chairman has led a delegation to various institutions across the globe as well as the country and has gone ahead to see how the incubations and innovation centers are going to set a benchmark for tomorrow. Having said that, again I welcome all of you for this beautiful conference. We the Oxfordites look forward to walk along with all of you in this path of innovation together. Have a great day of learning ahead. Thank you.
Thank you, sir, for providing us with a clear and concise briefing about today's IEEE ICCCNP 2025 conference. On behalf of the organizing committee, it's my pleasure to officially release the IEEE ICCCNP 2025 conference proceedings. I now request all our esteemed dignitaries to kindly join us for the release of the proceedings. I would request everyone to kindly join for IEEE ICCCNP 2025 conference proceeding release. Thank you for this wonderful beginning. We congratulate all the authors and participants whose contributions have made this possible. It is my privilege to introduce Mr. Vikas Gadi, Senior Director of R&D at Synopsys Incorporation. I now invite Professor Bindyashri to kindly come forward and present the profile of our esteemed chief guest for today's IEEE ICCCNP 2025 conference.
Mr. Vikas Gadi, with over 22 years of experience in SoC, IP and circuit design, he specializes in graphics processor SoCs, ID microprocessor core IP and advanced process technologies. He has successfully led teams of 100+ engineers driving RTL to GDS design, high-speed and low-power methodologies, ASIC PD with full custom designs. Currently with Intel Graphics SoC, he leads SoC design, low-power optimization, TFM and sign-off activities. His expertise spans Intel Discrete Graphics SoC, Intel 11 to 13 Gen X 86 core, memory compilers, high-speed and high-density SRAM, flow and methodology development SRAM, multi-port register files, ultra-low leakage designs, silicon debug and customer interfacing, making him a key contributor to cutting-edge SoC development. On behalf of the Oxford Engineering College, we warmly welcome you, sir. I now invite to kindly address the gathering.
Hello everybody, I'm audible? Okay, so respected IEEE leadership, distinguished professors, industry colleagues and dear students, a very good morning. It's a privilege for me to join you at this International Conference of Compute, Control, Network and Photonics here at Oxford College of Engineering, Bangalore. Thank you for inviting me and this warm welcome. My special thanks to Chief Patron Dr. S.N.V.L. Narasimha Raju sir. I think he's not here. Ms. Leela on the dais. Patron Dr. H.N. Ramesh, Principal and Director of Oxford College of Engineering. General Chair Dr. B.K. Manjunath sir. And Conference Chair Dr. Preeta Sharan ma'am for bringing us together. I'm honored to share the stage with our guest of honor, Dr. Francisco Morelli, Dr. Fikadu Miret Gerenu and Dr. Srinivas Talabatula, our keynote speaker for today. I'm also grateful to the organizing team and volunteers. Dear students and dear friends, honestly, today's engineering is an engineering of possibility. It's engineering of possibility and its override, which are complete constraints that override it. We have an extraordinary tools. If you really see, we have extraordinary tools at our disposal. We have AI at scale. We have advanced silicon photonics. We have programmable networks, and we have integrated photonics, and etc. etc. Yet our constraints are much sharper. We have big constraints like energy, safety, reliability, and equitable process. Great engineering today is not more of everything, but the intellect. Am I audible? Correct now, sir? Thank you. I'm sorry about all the confusion. Great engineering today is not more of everything, but the intelligent choice of the right thing. The right architecture, the right standard, and the right matrix. And I firmly believe the mindset is the core of our content generation engineer and IEEE. Dear students, if you come to me, I really follow 3 principles for the real world impact, and I call them 3 C's. The number 1, curiosity. Definitely and always ask better questions. Not only can it be faster, but should we build it? Just think over it. Whatever we are building, should we ever build it? Whether it's a small value that it is going to create when we build it. So definitely think over that before you try to design and build a system. And also always think, if I build it also, will I be able to deploy it safely? So if you see that, curiosity becomes a discipline that converts ideas into results. The number 2 is craft. Measure what matters. Let's widen success beyond throughput, energy per task, reliability, latency, fairness, and safety margins. When you change the metric, you change the design. And the number 3 overall is character. Use ethics as your design constraint. Privacy, robustness, accessibility, and environmental impact are not only the add-ons, they are a must in today's world. IEEE Code of Ethics is a specialization for decisions when nobody is listening. Thank you to the AI for actually establishing the guardrails around what we are doing today. Now let me talk a little about the ICCCNP and where compute, control, network, and photonics meet each other and combine with each other. If you talk about compute and control,
AI guiding real-time decisions, robots, grids, medical devices with clearly defined priorities, you will always get predictable latency and verified behavior. Now come to network. Think of network as a pacement engine. Prefer moving code, not raw data. And today, when I will be doing my plenary talk, I will be talking about how do you move the raw data or how do you move the code. Use programmable fabrics so that the tasks run where they add the most value. Cloud for training and edge for action. Save energy and make the world greener. So this is an absolutely important point today. We are developing so many new things, we are building new and new structures. What we are not thinking about is energy. At the end of the day, the energy has to be conserved, energy has to be created into a different form that we can use. Now coming to photonics. Photonics is there just for scale. They will, as electrical interconnects hit limits, silicon photonics and co-packaged optics promise bandwidth at a lower energy per bit. Very critical and crucial for AI clusters in the interconnected world. And finally, standards and interoperability. So IEEE is the superpower here. Turn demos into deployable systems across chiplets, interconnects, safety environment, and assurance. So this is where what your thoughts are and how you create your thoughts and how you connect them into systems. So this is where the guidance of the IEEE in terms of the standards that they create, they let you seamlessly connect across the systems and within the system. And now I'm coming to the words of wisdom and some gyan. My humble advice to the students and the early career engineers in this room. Number one, pick one hard lever and go deep. Algorithms, system placements or hardware. Be excellent in one and fluent in others. Number two, publish and productize. Share enough to move the field and ship enough to impact the users. So what I mean to say here is, we can create many things, but is it really valuable? Is it creating the value in the real world? And will we be able to ship it to the customers in time? Definitely think whenever you are publishing your thoughts and productizing your actions. Network with a purpose. So introduce yourself, ask two sincere questions, and propose one concrete follow-up. So whenever you talk to people, make sure it's valuable. It creates value of their time, it creates value of your time. Make sure that you connect two connections, you sort of deliver something and you receive something. Number four, always keep a lab notebook of your career markup. Track hypothesis, decision, failures and lessons. It is very, very important for you to figure out your graph. We do AI, correct? We do analytics, we track many things. So it's absolutely important for you also to track your career. How you hypothesize it, how you take the decisions, where the failure happens, and what lessons you learn from your failure. And fifth and the last, define your ethical red lines now. See, as we are moving around, the world is opening up. Okay, ethics is losing its value. So definitely we have to come back, figure out, can we go back and be ethical again? Definitely when pressure comes, pre-decided values protect you and the public. So if you don't have these values created in your mind, if you don't have these ethical guidelines, the product that you create will not create value for the system. So, and finally, coming to the call of action in this world of engineering, if you really see the world of engineering in which we are here today, it is full of a lot of constraints. And if they are not there, we have to create them so that we can guide our engineering decisions in the right direction. So, a few call of actions here. Measure. Add energy and data movement dashboards to your project. Why I am telling that to you is, if you don't care of energy today, energy will not care of you tomorrow. And if there is no energy, maybe your bodily energy or the energy that we are talking in terms of electricity, if it goes away, you will not be able to create what you want to do. So measure. Always measure what you are spending to earn what it is. It should be ROI in terms of energy, not only in terms of money. Second, standardize. Never ever go for customization, because customization solves the problem for a smaller society. Standardization solves the problem of a bigger society, and there is where the IEEE is all about. So, across the globe you can connect, you can try to deliver things and you can take it forward. So contribute a small but solid artifact. Always think about it. Maybe an interface spec, maybe a test suite, maybe a documentation template. But whatever you float will be globally used by everyone across the globe, and that makes the basis of what you develop, what you deliver, and what you take forward. With this, I close my thought today. I will be talking a little more in my plenary section today, where I talk about the energy and its contribution to the today's compute and the direction that we are seeing in AI. So, for today's thought, let me tell one more thing to you. If you do this, whatever we talked about in terms of energy conversation and all, we will not only keep pace with the future, we will shape the future and we will shape it not just faster, but smarter, safer, and kinder. Thank you, and with that, I will again thank Dr. S.N.V.L. Narasimha Raju sir, Dr. H.N. Ramesh sir, Dr. B.K. Manjunath sir, Dr. Preeta Sharan ma'am, Dr. Francisco, Dr. Fikadu, and Dr. Srinivas, and to everyone at the Oxford Engineering College of Engineering and IEEE who are present here, my fellow students, dear friends, people who welcomed us, for your kindness and for your humanity. May this conference spark collaboration that outlasts the event. Thank you.
Thank you, sir, for your valuable and effective guidance to our future engineers. Your words will truly inspire them to excel in their careers. As Ellen Kidder said, alone we can do so little, together we can do so much. Your words truly motivate us to achieve greater heights together. Now, with great anticipation, I would like to brief about keynote speaker for today's IEEE ICCCNP 2025 conference, Dr. Srinivas T. Dr. Srinivas T is a professor in the Department of Electronics and Communications at IISc, Bangalore. He obtained his BSc from New Science College, Hyderabad, and ME and PhD from IISc under Professor A. Selvarajan. He was a postdoctoral fellow at Kyoshi University of Technology, Japan from the period of 1992 to 1996. His research focuses on photonic integrated circuits, optical communication, optical sensors, and quantum information technology. He has guided 24 PhD and 5 MTech students and published 60 plus journal papers. He has served as chairman of GATE IISc Zone, as a member of BRICS and DST working groups on photonics, and a senior member of IEEE, holding leadership roles in IEEE Photonics and Communication Societies. We cordially welcome you, sir, to deliver today's talk.
It's only a few minutes talk. My real talk will come later as a keynote. So first of all, I'm very happy to come to your college for this conference. I would like to mention about 2 points. One about the conference and the other about the college. In the IEEE Bangalore section, last year we have sponsored about 42 conferences. One of them is yours. One of the objectives of IEEE Bangalore section is to raise our conferences to global level. So that is the purpose with which IEEE Bangalore section has been assigning a few ExeCom members to your conferences to oversee how it can be done and so on. Actually, it's a very simple algorithm to say how to raise our conferences to global level. At this moment at least, as we know that, of course, most of our conferences are not global level, I would like to first admit. It's a very simple thing. The organizers need to attend a few top conferences like GlobeCom, ICC or PIC to know what we should do. Of course, there is a different dimension to conferences happening in India. The logistics, then the other aspects, the organizing aspects are very good compared to even conferences outside. But we have to raise our technical level. For that, we need a lot of researchers in India. Every institution like yours should have a few researchers doing on cutting edge technologies, and we should go to the top conferences and so on and so forth. So coming back to the college, I am very happy that the college has come forward to conduct this conference. And I am also very happy that Dr. Felicitation has included photonics in the title, which is my area of interest. So, from the college point of view, as I mentioned, we need to have a lot of researchers. I hope, as a part of this conference or independently, the college will take up cutting-edge research. I was talking to your management and your principal several times, of course, whenever I came, that we should raise the research component of the college. As we observe, this is important because there is a lot of competition among colleges in India, particularly in Bangalore. There are so many colleges, about 150 student branches we have in IIT Bangalore section. So how do we distinguish one institution from another institution? The most important parameter that outsiders or the students or parents look at is the placements. First important component they look at is the placement. Then from a college point of view, we are interested in admissions. So they are both correlated. But from an academic point of view, from an academician's point of view, we would like to see the college raise higher and higher up. In that context, R&D is an important component. Every faculty member should take a little bit of time off from their regular teaching load, administrative work and so on to raise the standards of our R&D. So that will distinguish your college. It will also put in an equal basis or equal footing with coming up collaboration. There are many foreign universities coming to India. We will have to collaborate with them. So in that context, it is going to be an important aspect. I hope the near future, your college also will rise to, of course we always do a little bit of comparison. Let us hope that your college will become the Stanford University of India. Thank you very much and once again for calling me to the college.
Thank you, sir, for your inspiring, thought-provoking talk. Great conference doesn't just share just knowledge, they spark innovation. It gives me immense pleasure to introduce our today's guest of honor, Dr. Francisco Mauli. Dr. Francisco Mauli is a professor of marine systems and robotics at Constructor University, formerly at Jacobs University Bremen, Germany, where he also serves as a program chair for the Robotics and Intelligent Systems program. He earned his PhD at the Ocean Systems Lab, Heriot-Watt University, Scotland, with a thesis on intelligent localization of autonomous underwater vehicles. Mr. Morley has held positions including scientific manager at the Technical University of Munich, leading European initiatives to transfer robotics technology from lab to market, and was a Marie Curie Fellow at MIT. His research focuses on persistent anatomy of marine robotics, including perception, autonomous, navigation and intelligent decision making, and also the sensor data processing and fault management. Dr. Mauli is an executive committee member of a Global End Academy, co-chair of a technical committee in marine robotics, and co-chairs of the Young Professional Committee in the IEEE Robotics and Automation Society, and also a member of the Administrative Committee of the IEEE Oceanic Engineering Society. I now invite our guest of honor, Dr. Francisco Mauli, a Constructor University, Germany, to address the gathering.
Hello everybody. It's a great pleasure for me to be here. So thank you very much for the kind invitation. It's my first time in Bangalore, where I can meet you. I'm in the city. But I had the pleasure to visit India another couple of times. I've been at the National Institute for Oceanography in Goa, and I've been in Siri Pilani at IIT Hyderabad last June for a conference of the Global Young Academy. So I'm here to tell you a little bit about my journey in engineering and to inspire you a little bit, thinking about oceans, thinking about robotics, thinking about the world that is coming and the changes that we can have in that. Excellent. Thank you very much for a great team to sort all our PowerPoint presentations. So we can see a few of my friends, not every friend, but some of good representation. As you can see, they range from different marine robots, underwater, catamaran, that was in MIT and the Charles River in Boston, but also the very first aspects of autonomous driving. On the bottom left is our participation at the DARPA Urban Challenge in 2007. So it's a sign I'm getting older, but I'm still trying to hang on into the youth age. And on the side, we see what we teach with our students. So autonomous driving with a smaller kit in a concept called Back It Home, so that students can learn in the gamification aspects and can immediately connect to the automotive industry. A little bit about myself, you've heard about already. I'm quite active inside IEEE, and especially the Robotics Automation Society, Oceanic Engineering Society. And just at breakfast I've heard that the IEEE Bangalore section has overcome the Beijing section. So congratulations to everybody here and to the chairman. I come from Constantin University in Germany. We are an English-speaking campus-based university in the north of Germany, and it's a gateway to Europe. It's quite an interesting place. My office is just behind those trees, and we have different laboratories. In particular, relevance for us is all our oceanic robotics lab, or our service robotics lab, and industrial robotics lab that we have in our campus. And I'm here, but the work I will present is not only from myself, and I want to give credits to my team, different PhD students and postdocs. And I always use this slide, updating from time to time, of course, because people change, there are additions. Because in robotics, in engineering, there is no one person that alone can do everything. So you will always work in a team, leading a team or part of a team. And it's very important that you realize that your engineering skills, your scientist skills are great, but if you cannot put them together with the other people's skills, then they are really not worth much. So it's very important to think about your team, and especially some of you would be, most of you would be in a leading position, think about how you can manage your team properly. My main research interest is in autonomy. Now, autonomy for me is not just a robot with a big battery that can run for hours. And for me, autonomy, there is an aspect of intelligence inside. And this can be applied to many domains, from the underwater aspects, the depth of the sea, up to space. We have projects with the European Space Agency on understanding the moon, and thinking about robotic solution to explore tunnels on the moon, and we were using similar approaches that we used to explore the depth of the sea, or to explore disaster scenarios on land. And there are many different research areas that linking into autonomy, from navigation, organization, sensor data processing, knowledge representation, planning, and so on. But here we are at this ICCCNP conference. So let's see all these different keywords. So the first is compute. So why we need compute in robotics, in marine robotics? Well, first of all, we need computation in every aspect of intelligence, in every aspect of autonomy. It's not about the robot just giving power to the motor, but it's about taking decisions, taking smart decisions. So being able to sense the reality, understand the reality, there is a level of cognition, and there is a level of decision, where you take decision of what to do based on the reality. On the other hand, in marine robotics, this aspect is even more important, because we are used now to the hype of AI and deep learning, and we say, yeah, I have this huge network, I put it on training on this GPU rack for 3 days, and here are great results. Well, you don't have this power, computational power, in the sea. So we have to think about how to balance what we want to achieve with the computational resources that we have on board of a robot. A car is already different. I mean, a car has also limitations, but you can put some big computers inside. A maritime robot that goes into the depth of the oceans doesn't have big computational capacity. There is a physical limitation on the things that we can put there. There is a physical limitation of the cooling aspects, on the pressure aspects, and so on. So compute takes also a very different flavor when we think about maritime robotics. What about the second C? Well, control. Well, control is the basics of any robotic system. Now, control systems, at the very minimum, everybody should know the basics of a PID as the very basics, up to much more complex control level, based also merging with deep learning and so on. Then we get into network. And network underwater also takes a very different approach than on air. And here we are all connected with mobile phones very easily. We can talk to each other. There is Wi-Fi. There is no such things in the water. The Wi-Fi signal doesn't propagate in the water. You have a drone, you have a land robot, you can put an antenna and everything, you can control, everything is fine. You can have two robots communicating through Wi-Fi. We cannot have this underwater because Wi-Fi signal doesn't work. To localize yourself, everybody is on Google Maps, your nice blue dots in the map. Well, GPS doesn't propagate underwater as well. The electromagnetic waves are absorbed in a few centimeters of water. So you cannot use the same techniques you're used to work as human or in other robotics domain like with drones or with land robots. So what do? Well, we use acoustic mostly. So acoustic is the way that you can see. Acoustic is the way where you can communicate between different robots. Of course, the bandwidth is limited, it's very noisy, high error packet rates, many challenges. And that is also why I'm interested in maritime robotics, because it's a challenging area where there are always problems to solve. And then we get into P, photonics. Well, there are two interesting aspects about the P in the maritime domain. One, of course, is the lights, the photons from the lights. And lights in the water also is very different than lights outside the water. Now, color is different underwater. Because we see lights, but lights is not only a light. Light has different wavelengths. And different colors correspond to different wavelengths of the electromagnetic spectrum. Now what happened, the water absorbs some of these frequencies. So the red channel, for example, disappears. So you don't see red underwater, not because things are not red, but because the red channel just disappears. Then if you put your lights on, you have a phenomenon called marine snow, because the water is not empty. There are a lot of different particles. So as soon as you put lights on, you see a lot of particles moving on that is similar to snow. And sometimes in turbidity, you cannot see more than a few centimeters sometimes. If you are lucky, you can see up to 10, 20 meters. So these are all challenging in vision aspects that we try to address. At the same time, thinking about photonics, another aspect is also connected to the previous networking aspects. I said that we use acoustic, that is true, but we can also use optical modems. So we can also use lights in order to communicate. So we have done different tests where we have two robots communicating a much higher data rate using lights with each other. And these are only possible thanks to advances of engineering. If we think about all the aspects connected to an intelligent system, starting from the sensor perceptions, based on the perception from your sensor, you define your plan, you define what you want to do, and then it gets to the control aspects, and then to the actuation, to the motors. We see that compute, control, network, and photonics are in all these loop. And this loop is also the loop that we use to do every day, every second as humans. So for me, when I was walking from the chair to here, I was always looking at my steps, and I was readjusting my trajectory. The same you did to come to this building. And if you were coming to this building and somebody was saying, hey, the door is closed, so you need to make a different route, then you would start a planning. You wouldn't continue your original plan. But based on your sensor, you start a replanning, and then you give control to your legs to move. And this circle is what happens every day, every second, every milliseconds in humans, and what happens in robots as well. Where computation is there, the control aspects of robotics is there, the networking aspects is there, robot-to-robot collaboration, and the photonics aspects is there for the sensing and perception and networking aspects. Now, why do I focus on maritime robotics? Well, you know, marine robotics is a very interesting field, but you can say, you worked on autonomous driving, why didn't you keep working on your autonomous driving? Or you mentioned this boom project, why didn't you keep working on that? Why do you want to focus on marine? Well, you know, let's take a small break. Let's take 2 deep breaths with me. Now, the second breath came from the oceans. So the oceans gives us more than half of the oxygen that we need to breathe. If the oceans is ill, we get ill as humans. If the oceans die, we die as humans. In addition to that, of course, oceans allows transportation. More than 90% of the volume of shipping is done through oceans. Resources, oil and gas, and you may think also quite rightly that oil and gas are actually quite bad for the environment. That is true, but even so, at the end I had to fly here, and it's much better if we can use robots to control, to inspect those subsea infrastructures and to take actions immediately to prevent damages to be done. Renewables, that's fine. Lots of renewables are in the sea, offshore wind farms, for example. And then we get, of course, into aspects of geopolitics, defense. The water is a very important aspect for sovereignty of different states, for safety, security, control, anti-terrorism, defense, and so on. More than 2/3 of our planet are covered by water. The maximum depth is 11 kilometers, and more than 70% is at a depth greater than 200 meters. No diver can dive easily at that depth. We need robots, not because we don't want to have divers, just because it's impossible to stand the water pressure at this depth. And you know, we know so little about the oceans. I've been working with the European Space Agency. I've seen a very detailed map of the moon. We know so much details about the moon surface, and we know so little about the depth of our oceans in our planet. We know more about a rock so far from us, and we know so little about the depth of our oceans. Now, nowadays, these kind of robots are routinely used in many industrial applications. These are called remotely operated vehicles. Now, remotely operated vehicle is a very expensive expensive toy. So when I was a kid, I could have a small joystick and I could play with a car that was moving around in my place. Well, it's exactly the same, almost exactly the same, just way more expensive. Almost exactly because radio waves, Wi-Fi doesn't propagate. So in order to control the vehicle, these guys have a very long cable. So we see we have a ship, and we have a cable, and then we have a tether management system. You cannot have all the cable in the water, you cannot have too little cable in the water. So you need to have a management of the cable in and out. And then the robot inside can do different things in the water, can manipulate valves, can do inspection of infrastructures, can collect rock samples, water samples, and so on. Now this is great. It's a marvelous engineering activity. On the other hand, it's very expensive because you need to have a ship that is there. You need to have a human pilot, and when the ship is there, no other scientist can do anything because you are attached with a cable to the robot. Wouldn't it be much nicer if you could cut the cable? Just tell the robot what we want. We deploy the robot does its mission. The ship can do other things, can come back, and then we can recover the robots and continue our work. Now, a very good thing is that the human is in the loop. Now, when you talk in companies, of course, they like to be in control. Whenever you talk about autonomy, they are very scared. They say, no, 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 no. I want to understand what's happening. I want to take the decisions. So the human decides, that is very good. The other aspect is that we have cables, so we can give high power to the robot. We don't have problems with batteries. We can have lights, and we don't have to think about how we're running out of juice. And because we have a cable, we can have a live video feed. So as I said, there is no Wi-Fi. Acoustic communication is very short in bandwidth. So we cannot have any live video feed without a cable. So this allows the humans to take decisions based on the situational awareness. Now on the plus side, we have a great aspects of these robots that are underwater and controlled by humans. But there are also some negative aspects. Well, the human in the loop is very good from one side, but it's also very bad from the other side. Why is very bad? In our computational capacity that goes back on the sea in terms of compute is actually much limited than a computer. And sometimes a robot can be at 2 kilometers depth, and it has sensors to understand the currents, to understand the situation. What do you know? You are on a ship, in a container, moving around. Your computational capacity are not the same as the robot, so the robot may be able to take much better decisions than you. In addition, as I mentioned before, we do need a vessel, and that means that the cost is very high. Every hour of a vessel can be thousands and thousands of dollars, because you have not only the petrol, you have all the people around, the captain, the support staff, the scientist, the cook, and whatever, and everybody is blocked when the robot is in the sea. They cannot do their job because the robot is in the sea and the ship cannot move. In addition, there are very interesting areas where a cable is really a problem. For example, cave explorations, underwater caves. You cannot enter into an underwater cave if you are attached with a cable, because the cable would just get stuck and would limit your motion. Under ice exploration, you cannot do under ice exploration with a cable. And that is a very important area, not only because we are curious about that, but also because we need to monitor what's happening. For two reasons. There are two use cases. Well, with global warming, the ice is melting faster, and there are more and more icebergs coming off the coast of Canada and US. So they need to monitor this iceberg coming, they need to understand the dimensions, they need to understand what kind of threat it is. So there was a project run by my colleague that was trying to estimate iceberg trajectory and iceberg volumes based on maritime robotics. So you were going down and you were trying to go down the ice to try to understand the dimensions. Then you have explorations under ice in the North Pole, and that is done in order to understand the consequences of ocean acidification, climate change, understanding the health of the oceans, if the ice is melting or not. So you need to go under the ice in order to understand all these phenomena. You cannot do that very easily if you have a cable attached. So we want robots to be without a cable, but in order to be without a cable, they need to be smart. They need to be able to take decisions based on the changes in the environment. And you know, the underwater domain can be very, very dynamic. The elements that you put there can be corroded. We were doing some oil pipeline following in the North Sea. We had a map of the pipeline. The real position of the pipeline was very different from the map, because everything happens in the field. Things do not stay static. In addition, universities are great at doing research in a lab, and then maybe it fails 100 times. You manage to get it working one time, you record the video, you publish a paper, and then you tick a box. Well, that is not really something that would work in the field. Something that works in the field for extended long time needs to be robust to failures and to problems. And you know very well failures do happen. Mechanical failures, hardware failures, or even software failures. So we need to make sure that the systems that we develop are actually robust enough in failures. So current autonomous underwater vehicles are great, but they are great at very simple missions, usually a monitoring mission called the standard lawnmower inspection. Called like a lawnmower because the robot moves like a lawnmower cutting the grass and then gathers data. This, of course, is not really high level of autonomy, because there is no reaction to the environment. There is no decision on board, there is no cognition, there is no central data processing and signal processing. So that is why we developed a system where we put a cognition system at the very heart of our architecture. So our knowledge base gets input from sensor data processing, is able to address calls, and is able to work with a high-level planning system. So that your plan can change or can be adapted based on the changes of information in the environment. You know, also, as Indians, similar than Italians, we always need to adapt. So in the way as we adapt, we are driving, the road is closed, we need to take a different route, or we have to schedule a certain time, and then something happens. We adapt all the time. As I'm Italian, I adapt all the time the same way. But robots do not have this capability, and this is key in order to have them persistently operating in the field, not in a simulation, not in a lab for 30 minutes after failing several times, but sustainable operation long-term in the field. Here are some of the results of some sensor data processing from our group. So the first aspect is actually even relevant for some of the sponsors of the conference, because it's about understanding the structural integrity of infrastructure. So this is about understanding cracks in dams or bridges or any concrete infrastructure in the sea. And you want to service and you want to understand cracks and you want to understand problems early enough, because a problem, if discovered early enough, can be solved. If you discover a problem too late, then you cannot do very much. Similar to health of people, is the same. While there is a lot of emphasis about prognostics, diagnostics, regular checkups, Because if you find an illness soon enough, you can cure it. Similar for infrastructure. The one on the right is very different. It's about understanding the environment. We are in the Mediterranean Sea, where the hydro vents, natural hydro vents, sipping gas from the seabed. So this has a lot of impact for the local community because this island was closed to tourists for several months due to increased hydrothermal activity. So we went there with the robots to try to understand the impact of the gas in the water and to try to compare in the year, because we went there several times, what are the changes in the environment, in the salinity, pH, and all aspects of the water, in order to make a prediction and prognostics about the future and give some assessment of the health to the authorities so that they could decide based on data if closing the island to tourists or not. And I mentioned that photonics is very relevant because photons are actually traveling in the water in a very different way. So this is a work that we did in order to enhance images. I mentioned that the red channel is going down because the light is absorbed. So this is a work that we did in order to add the red channel back in an explainable way to clarify all the steps involved. Different sensor data processing through acoustic, multi-vehicle missions, the networking aspects, localization, and here we get an interesting aspect about faults. And when we think about faults, we always think about simulating a fault because we don't want to break our robots, right? But actually it happened to us that one of our robots did break, and we could actually see that our algorithm for fault management, so detection of a trusted fault, was actually very good. So it managed to detect the fault that happened in real, we didn't expect it, and it managed to change the dynamics and the trusted allocation metrics in the robot for the robot to continue its mission even in order to finish. I'm about to finish. I just want to show you a couple of videos. For the video. And these are some of the work that we did in different places in the world, from Italy, Spain, and in order to showcase the advancements in manipulation, intelligent decision making in maritime robotics. I hope that this was interesting and inspiring, and I'm looking forward to talk to you in the next days. Thank you.
Thank you, sir, for giving the brief encapsulating the technology, and the students and researchers can make use of it in a vast way. And also your talk insights truly inspire us to learn and grow. Now I invite one of our sponsors, Mohammad Ramzi, Regional Director, MH Group, CHEAMAHZ, to address the gathering.
Hello everyone. So it's an honor to be here to participate in this particular event. And firstly, I would like to take this opportunity to thank the Oxford College of Engineering Management to give us an opportunity to become one of the supporters of this IEEE conference. So IEEE has always been about ideas that move the world, and it's very exciting to be a part of this particular energy today. And my name is Ramzi. I represent AHZ. We are one of the official UK university representative. We are working with more than 130 plus universities directly in the UK. And we have branches in India across 7 states, and globally we are working in almost 15 plus countries with 600 plus staff. And we can tell proudly that we are one of the education consultant having or maintaining 100% visa success ratio to UK for the past many years. It's mainly because we have our all education counselors are British Council certified, so they know what exactly they have to train the people. And also we have been recruiting students, we have been counseling the students, especially from all the backgrounds including engineering, and we became one of the path for many students to bring their career to an advanced level. Our mission is simple, that we want to help our talented students, like many of you here, and finding the right academic path for them so that they can secure their career in the right respected way. So it's all about you guys, that how you wanted to take the opportunity, because many of you are here, already have a plan, what you have to do after your graduation. Many of you wanted to secure a job, or many of you already plan that you wanted to study further in any other countries. So whatever it is, I would like to recommend you all that make your plan properly. Definitely it's your career, and we are always available here. If you have any plan to study in the UK, we are more than happy to support you. You can contact us anytime. We have a strong team in place who can support you from the beginning of the journey till the end of the journey. We will make your journey smoother. We can provide you the very detailed information about all the universities which we are working with, and definitely through us you can have a smoother journey if you are planning to study abroad. And again, I would like to thank you all of you here. And please take this opportunity of IEEE, because you can learn a lot of things in this sort of conferences. Once again, thank you everyone. Thank you.
We sincerely thank you, sir, for your valuable support. It is our privilege to welcome our guest of honor, Mr. Fikadu Mehret Review. Mr. Fikadu Mehret Review received his BSc in Electrical Engineering from Arba University, MSc in Electronics and Communication from IIT Roorkee, and PhD from the Indian Institute of Science. He has served as a lecturer and assistant professor at Arba University and Bihar Dar University, and is currently a visiting faculty at Indian Institute of Science. His research interests include wireless communication, microwave photonics, optical communications, signal processing, and machine learning. May I now invite our guest of honor, Dr. Fikadu Mehret Review, to kindly share his thoughts with us.
Thank you very much. Distinguished delegates, esteemed colleagues, organizers, and participants. It is both a great honor and privilege to stand before you today as a guest of honor at this prestigious IEEE Data Conference on Compute Control Network Photonics here at Oxford College of Engineering, Bangalore. First, allow me to extend my heartfelt gratitude to the organizing committee for inviting me. I would also like to recognize the contributions of our distinguished researchers, industry partners, students who have gathered here from across various places. Your presence makes this gathering not just a technical meeting, but a celebration of collective knowledge and collaboration. This conference stands at the intersection of computation, control networks, and photonics, a combination that defines the future of digital society. Each of these fields is powerful in its own right, but together they unlock transformative innovations. From intelligent networks and autonomous systems to quantum-inspired photonics and 6G wireless technologies. Photonics in particular has become the backbone of modern communication.
As we move toward a hyper-connected future, the role of integrated micro-photonics is enabling high-speed, low-latency, and energy-efficient wireless networks, which cannot be overstated. Bangalore, known as Silicon Valley of India, provides the perfect backdrop for discussion with its rich ecosystem of innovation, startups, and global technology leadership. As a guest of honor, I would like to emphasize two messages. One, collaboration is the currency of progress. No single country or institution can solve the challenges of next generation communication. We must work across borders, disciplines, and industries. Two, the future belongs to the young generation. Students and early career researchers present here are architects of tomorrow. I encourage you to think boldly, cross traditional boundaries, and never stop questioning. Let this conference not only exchange knowledge, but also ignite partnerships that continue for beyond these today's. I once again thank the organizing committee, the IEEE, and Oxford College of Engineering for arranging this platform. May ICCCNP 2025 be remembered as a milestone in the shaping the future of global communication and photonics. Thank you very much.
Thank you, sir, for your inspiring words. As Confucius said, education breeds confidence, confidence breeds hope, hope breeds peace. We now felicitate our distinguished dignitaries as a token of our gratitude, love, and respect. May this moment serve as a reminder for their invaluable contributions to academia and research. Now I would call upon all the dignitaries to felicitate our chief guest for the day, Mr. Vikash Gali.
Dr. P.K. Manjana, Dr. Srinath sir, Dr. Preeta and Shakuntala ma'am, please join.
Thank you. Now I would request all the dignitaries to kindly join for the felicitation of guest of honor for the late Dr. Francisco Maurelli. Thank you, sir. Now we would like to felicitate our guest of honor, Fikado Maharat Girimio. Thank you. Thank you. Now we would like to felicitate our keynote speaker, Dr. Srinivas. I would request all the dignitaries to kindly join for the felicitation. Thank you. Now we would like to request our management representative, Ms. Leela Lakshmi Raju, for felicitation by the dignitaries. Thank you. Thank you. As every program has a beautiful beginning, it must also have a graceful conclusion. To conclude this inaugural ceremony, I now invite Dr. Felicitation, Conference Chair, to deliver the oath of thanks. Good afternoon to one and all. On the dais, off the dais. First of all, being IEEE branch councillor, I would like to take this opportunity for 2 minutes about the Oxford College of Engineering student branch. IEEE student branch we started in 2011, sir, and since 2011 we formed 5 society and 2 affinity group. It means we are having the very high motivation for the research. So our faculty are involved in SPS Society, Robotic and Automation Society, Photonics Society, EMBS Society, and now very recently we started WI Women in Engineering Society, Affinity Group, and SITE, which is the Special Interest Group for the Humanitarian Technology. And in this year of the journey, since 2011 till today, I can say that our student and faculty achieve number of awards, not only from the India, but from the Asia Pacific Award. And because of those Asia Pacific Awards, they went to very high university ranking research for the higher study. So I am very thankful for management, principal and staff for this cooperation for our IEEE student branch. Now I will take an opportunity to give the vote of thanks. So on behalf of the organizing committee of ICCCNP 2025, hosted by the Oxford College of Engineering, it is my proud privilege to deliver the vote of thanks. First and foremost, I extend my heartful gratitude to our esteemed chairman, Dr. S.N. Narasimha Raju, chairman of the Oxford College of Engineering, and Miss S.N. Leela Lakshmi Raju, academic lead of the Oxford Educational Institution, for their constant guidance, encouragement, and visionary leadership, which has made this conference a reality. We are deeply honored by the presence of our chief guest, Sri Vikas Gari, Senior Director R&D, Synopsys Bengaluru, who shared the invaluable insight and inspired us with his words. I sincerely thank our guest of honor, Dr. Francisco, Constructor University, Germany, and Dr. Ricardo from the Bahir Das University, Ethiopia, Africa, for gracing this occasion and sharing their thoughts that have truly enriched the conference. I would also like to place on record our deep appreciation to our distinguished speakers, Dr. Srinivas T, Professor, Department of ECE and past Chair of IEEE Bangalore section. Your presence and contribution have added immense value to this conference, sir. A special word of thanks to IEEE, our advisory and technical committee session chair and reviewers who worked tirelessly to ensure the academic quality of this event. I sincerely thank Dr. Srinath Reddy, our management representative, for his constant encouragement and giving the visionary ideas to make this conference successful. I also thank our sponsorer, faculty colleague, organizing committee members, and the dedicated student volunteer of the Oxford College of Engineering, whose commitment and hard work ensure the smooth conduction of this conference. Finally, my heartiest thanks to all the delegates and participants both from India and abroad for joining us, presenting your research and making this event a truly global platform of knowledge exchange. As we conclude today's proceedings, I hope that the deliberation and discussion of ICCCNP 2025 will inspire further collaboration
innovation and excellence in science and engineering. Thank you very much. I want to see you all next year 2026, ICCCNP NP 2026. Thank you very much for being here.
Thank you, ma'am, for summarizing and concluding the program with your vote of thanks. Let us all rise together for the national anthem, a proud symbol of our unity and patriotism. National anthem in chorus.
पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गारे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
बोलो भारत माता की जय वंदे
Thank you all. I would request everyone to please take a break for 10 minutes and come back to the same room for the further continuation of the proceedings.
Students, sit down, please. Sit down, please. Boardroom is open, no? Boardroom. Oh,